Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-6 Extra Practice Number 4 solutions on exponential equations. This one we're going to have to use logarithms and the calculator. There's a puzzle that goes with this one as well. Let's take a look at that. For our puzzle, we're trying to solve the riddle of why do shoes make poor debaters? And then we have these different equations we have to solve, rounding our answer to the nearest hundredth if necessary. And then when we get an answer to one of these letters, we're just going to put it above the blank that has the number involved. Now, you also might notice that some of these numbers get repeated, like this -1 gets repeated, and there's some others. So expect to use some of these letters multiple times after you solve this. So with all that said, let's go ahead and start solving. Here we go with our opening problem, which is problem letter R. So my general strategy on all these problems, I'm going to try to get some number to an x and then take the log of both sides to pop that x out of exponent land using my log rules. So that's the basic strategy. I might have to do some things, though, before I can end up applying that rule. So on this first one, though, we've already got this exponential term all by itself. So I am going to start by just taking the logarithm of both sides. So I have x log 3 on the left side, because if you take log of something with an exponent, the exponent can pop out as a multiplier. And then on the right side, I have log of 8, because I have to do the same thing to both sides of the equation to keep it balanced. To solve for x, all I have to do now is divide both sides by log of 3. And I'll just plug that into my calculator. So here I am on the calculator. Just move it over a little bit. And I've got log, which is right here, log of 8 divided by log of 3. I'll do a lot of this off camera, but I'll show you for now when there's something that we haven't done in this video before. And then press enter. And that's about 1.89. Now when you do this on the calculator, make sure you close that parentheses before you do the division. Otherwise, you're going to get a much different answer. So we got 1.89, roughly, nearest hundredth. That is over here, and there's only one of those, so that gets an R. For problem H, I've got 5 to the x plus 1 equals 12. Now there's a couple ways you could handle this problem. You could split this left side up into 5 to the x times 5 to the 1, and then divide both sides by 5 and isolate the exponential term to have just an x up there that way. Or you can just take the ln of both sides with the log of both sides right off the bat. I did that approach. So we have x plus 1 coming out as one big multiplier after the log of 5, and then we have log of 12. Now, I could distribute this log of 5 here, but what I'm going to do instead is just divide both sides by log of 5. That gets the x plus 1 out of the exponent, or out of the parentheses rather, right away. So we have log 12 over log 5. And then I'll just subtract 1 from both sides. I'm doing all this on my calculator anyway, so what does it really bother me to do it this way? Just to make things a little easier on my calculator, I'm going to start using fancy fraction mode for a lot of these log expressions. So at least on the grapher, I'm going to do alpha y equals n over d, and then I can write log of 12 over log of 5. Then I'll get out of that fraction and subtract 1. This fancy fraction is really helpful. It takes care of all the order of operations things that go on in fractions. So doing all that now, I end up with about 0.54 for an answer. And 0.54, there's one of those right here, so that's an H. And I don't see any other 0.54s, so it's on to the next problem. Next up, problem I. We have 7 to the 2x equals 11. Now, one way you could start this problem, because you've got this 2 inside the exponent that's kind of messing things up, you could do 7 squared to get 49, and then you'll have 49 to the x equals 11. That would actually be not a bad way to do this one. I did it a different way, though, so let me show you my other approach, which was to take the log of both sides right away to get this 2x out of there. So 2x log 7 equaling log 11. And then to isolate x is pretty easy here. I just have to divide by everything that's not x. So dividing by the 2 and the log 7, putting all of that in the denominator under that log 11. Plugging this in the calculator is a little bit tricky though, so let me show you that. So when you do this on the calculator, it's a good idea if you can use this fancy fraction mode, fancy fraction, to go ahead and do it because it'll take care of order of operations. So if I do 2 log 7 down here, I'm good to go. Now if you don't use this fancy fraction mode, you're going to have to put a parentheses around the 2 and the log of 7 if you're just using a regular division symbol. Otherwise, the order of operations is going to cause you to multiply by the log of 7 instead of also dividing by it. But if you do this fancy fraction mode, it's all taken care of for you. So that should give us 0.62. Now, if you don't believe me, check this out. Log 11 divided by 2 log 7, just regular division symbol, and we get something completely different. So you would need a parentheses if you did it that way. So 0.62 is the answer we're looking for. And that's going to be right here. That's actually an answer choice. So we'll put an I right there. And I think that's it. So on to the next. On problem S, our typical move of taking the log right away to pop out the x's is going to run into a few issues. I mean, we could do it here, but then you'll have x log 5, x plus 1 log 3, and at this point you're going to have to do some distributing and combining of logs and factoring out of things. It's not a lot of fun. So let me show you another approach, which is to try to get only an x in the exponent for each of these bases. So I can split up this 3 to the x plus 1 into 3 to the x times 3 to the 1, essentially unmultiplying these. Because if I were to multiply these back together, I would be adding the exponents and getting x plus 1. So I'm going to be doing this a lot for the rest of these problems here. Now, what I also want to do is get the exponential terms together by dividing here. So I have 5 to the x divided by 3 to the x, equaling that 3 to the 1 over there. Now, the reason I've done this is if I have division with the same exponent, I can actually unexponentiate that and turn that into 5 over 3, all of that just raised to the x power. Because with exponent rules, if you're raising a fraction to a power, the numerator and denominator are both getting raised to that power. So I'm just going reverse order of my regular exponent rules. And at this point, I now have some number to x equaling some number. So this is a pretty easy point at which to pull the logarithms in here and do that dance. So I'm going to have x log of 5/3 on the left side, and then log of 3 over there. And then to solve for x, I just have to divide both sides by the log of 5/3. So of course, plugging this in the calculator is a little bit of a mess, but let's go ahead and do that now. So on the calculator, I'm going to do fancy fraction to get the big fraction here with the log of 3 in the numerator. And downstairs, I'm going to have a log that I open, and now I'll do another fancy fraction to get my 5/3 in there. Although I could just do 5 divided by 3. I don't really need the fancy fraction. I just like the way it looks. And then pressing enter on all of this, we end up with about 2.15. So 2.15, that's going to be one of those right here. So there's an S. And do I have any more? Oh, yep, there's another one. So S there as well. For this next problem with 2 to the x plus 1 equals 9x, we've got kind of the same situation we had on the very last problem, so I'm going to handle it the same way. I'm going to split this 2 up into a 2 to the x times 2 to the 1, and then I'll divide to get this 2 to the x over here with this 9 to the x. Now that I've got those together in one big fraction, I can take the x out of both of those and rewrite that as 9/2, all of it to the x power. And now I'm ready to take the log of both sides. So we have log of 2 and x log of 9/2. And to get x, we just divide both sides by the log of 9 over 2 and plug it all in the calculator. So I just entered it off camera. Here is all of that in the calculator. Press enter, we get about 0.46. And 0.46 is right there, so that's u. For this next problem, we've got a different situation. Instead of having things added inside the exponent, now we have subtraction. I can still split these bases up, however, but instead of doing 3 to the x times 3 squared. Since I have a negative in here, since I have subtraction, that means I have to turn this into division. I'll have to write this as 3 to the x divided by 3 squared. Because if I were to divide these bases, I would subtract the exponents and get this x minus 2. I'm going to do the same thing over here. I'm going to write this as 5 to the 1 divided by 5 to the x. And at this point, I'm going to do that dance of trying to get the exponential terms together and everything else on the other side. So I can cross multiply in this situation. That gives me 3 to the x times 5 to the x on one side, and 3 squared times 5 to the 1 on the other. Now I can factor this, or not really factor, but unexponentiate this x out on the left side and have just 5 times 3 inside of parentheses with an exponent of x. Because if I have an exponent and multiplication inside, I'm allowed to essentially distribute that x to both of those as exponents. Now on the right side, we've got 3 squared, which is 9, and we also have a 5 there, so 9 times 5 would give me 45. On the left side, let's clean that up just a little bit to get a 15 in there. So I have 15 to the x equals 45. Now I can just take the log of both sides. You might have noticed that I'm holding off as long as possible before I start taking logs. That's on purpose. I just don't feel like messing with moving those all over the place. So we have x log of 15 on the left and log of 45 on the right. Divide both sides by log of 15 to get x by itself, and we can do that on the calculator pretty quickly. So log of 45 divided by log of 15 comes out to 1.41. And 141, I see one of those right there, so there's a t. And are there any more of those hanging around? Nope, that's it. For problem D, we have a 5 out here with this 3 to the x. Unfortunately, I cannot just multiply the 5 and the 3 together. What I can do, though, is divide both sides by 5 to get the exponential term by itself. So 3 to the x equals 7/5 would be a good first step. And then I'll just take the log of both sides. So we have x log 3 equaling log of 7 over 5. Now I just divide by log of 3 to get x by itself and do all that on the calculator. Crunching those numbers on the calculator, we've got 0.31 for this answer. 0.31, let's see, there's one of those right there, and that's a D. For problem A, I've got a 2 to the x and a 3 to the x all ready together on one side. It's not ideal, but what I can do is take an exponent of x out of both of those and move the 2 and the 3 together inside of parentheses being multiplied. I can just turn that into a 6 to the x now, just to make things a little bit nicer to look at. And at this point, we're ready to just take the log of both sides. So x log of 6 equaling log of 8. And then just divide both sides by log of 6. Calculator time. So log of 8 divided by log of 6 ends up giving me about 1.16. So that's an A going in this spot right here. And let's just double check. Oh, there's another one, 1.16. So there's an A. And that's it for the A's. For problem L, we have 5 times 3 to the x. We already know we can't multiply those together. So let's get that 3 to the x away from the 5. Instead of dividing by 5, though, I'm going to divide by 3 to the x because there's already a 4 to the x on the other side. So I'm trying to get like things together. So 4 to the x over 3 to the x. Then I can take an exponent of x out of 4/3. And now just log both sides, so log of 5 and x log of 4/3. Dividing both sides by log of 4/3, let's see what that gives us on the calculator. Plugging all that in, we end up with about 5.59. So that's L. 5.59, I see one of those right there. So there we go. And that's it. At this point, you might have noticed 2 facts. Fact number 1, there's 2 problems left. Fact number 2, there's way more than 2 blanks. However, if you look at the numbers underneath these blanks, there's a whole lot of repeats going on. So we're going to solve the rest of this now in these next two questions here. This one's a little bit of a doozy, though. We have some subtraction, we have some addition in exponents, and we also have this times 3 kind of messing up the works here. So I'm going to start by turning this 2 into 2 to the x divided by 2 to the 1. I'll still keep this times 3 around for now. And then over here, I'll make this 5 to the x times 5 squared. Okay, what else can I do to make my life a little bit easier? So I'm going to do a couple things. First thing I'm going to do is I'm going to divide both sides by 5 to the x to get it underneath the 2 to the x. So I can definitely legally do that. And then I'm also going to have to get all the other stuff over to the right side. So there is initially a 25 over here. 5 squared is 25. I can multiply 2 by that to get a 50 in the numerator over there. And then I can divide by this 3 to get it in the denominator over there. So at this point, I can take an x out of a 2/5 on the left side. And now it's log time. We have x log of 2/5 equals log of 50/3. And then just divide both sides by log of 2/5 and plug that mess into the calculator. So there's all that plugged in. I used a fancy fraction 3 times on this, and this is where it really pays off because you can see everything all at once without a bunch of parentheses. So pressing enter, we end up with a negative 3.07. I think that's maybe our first negative we've gotten so far. All right, so where do I have a negative 3.07? We've got one right here, so that's an E. We have another one over here, that's an E. Got an E down here. We have an E here and at the very end here. So that's 5 different times we got to use that. But E is the most commonly used letter in the alphabet, so I guess that makes sense. On to the last question. Here it is, final boss battle for this one, the letter Y. So let me start by breaking up these bases a little bit. I'll write this 3 to the x plus 1 as a 3 to the x times 3 to the 1. And this 2 I'm going to split up into a 2 to the x divided by 2 squared. And that 8 to the x is still over there. At this point, this is kind of a mess. I'm going to try to get the constants on one side and the exponential terms over to the other side. So I'm going to keep my constants on the left side here. I'll have a 3 to the 1, and I can put that over 2 squared. If I'm multiplying all these things, then 2 squared is in the denominator. And now I'm going to move my 3 to the x and my 2 to the x over to the other side by dividing by each of them. So I'm going to have an 8 to the x divided by 3 to the x times 2 to the x, all in one big denominator. At this point, I'm going to clean up my left side a bit. I can write that as 3 over 4. For the right side, since all of these are being multiplied or divided and they all have the same exponent, I can actually take that exponent of x out of the whole thing, and inside I'll just have 8 over 3 times 2. And you can double check, but if you have all of this to the x, you can apply that x to each of those individually. All right, so this 8 over 3 times 2, that's really 8 over 6, which I'm not going to write. That's just kind of a simple step. But 8 over 6, here's the interesting thing, that can be reduced to 4 over 3. I could use logs at this point, but I actually don't need to. 4 over 3 is the reciprocal of 3 over 4. So the thing I need to plug in for x to turn 4/3 into 3/4, I just need the exponent -1. So x just equals -1 just by kind of figuring out what exponent you need here. So that is our final answer. That's going to be a y now, going in those 2 last spots, which we kind of already knew it would, but there it is, we earned it. Now we filled in all our blanks, we're ready to move on to solving the riddle. Why do shoes make poor debaters? Because they are easily swayed, right? Like suede shoes and swayed in a debate. Till next time, Mr. Sutton signing off.